Hello and welcome to this tutorials. I'm Wemgon Benaya, industrial computing teacher, and I'm going to be taking you through a series of videos on practical exercises in industrial computing. The first thing is we want to know the purpose of these videos. Purpose of these videos are designed to accompany the industrial computing practicals manual, and they go a long way to reinforce practical understanding for both the learner and the instructors. Equally demonstrate correct laboratory practice and safety. Will support self-study and standardized demonstrations for instructors. So basically, students will be able to follow the videos and realize the practicals or the practical activities in the manual. The next thing we have is that the videos will all have this same or similar structures, where we start with the title screen, we go to the objective of the practical, go to the components or the tools that will be used in the particular project. Then we go to the next section, which is the testing and the results. We have the practical demonstration, then the testing and results. We go to common mistakes and tips, where I'm going to be giving some common mistakes that I usually made and some tips how to avoid them. And after that, we have a closing, and that will be the end of each video. So what I'm going to do now is to just give a quick rundown of all the videos we intend to cover in this series. And the very first set of videos has to do with the first part of our manual, which is introduction and safety. This is optional, as much of it is trivia and students can do them on their own. Right, so we have the introduction to industrial computing, laboratory rules and safety, safety symbols and personal protection equipment, electrical and electrostatic discharge safety. We go to the next area, which is logic gates and digital systems. For this one, we're going to be using logic sim to simulate different logic gates, different logic circuits, electrical circuits that can be simulated. The main purpose of it is for logic gates and other digital systems. These are the projects we're going to realize in this series. Our next part will be algorithms. We've traditionally done algorithms only theoretically, right? But we're stepping it a little further by being able to simulate it in a software called Flowgorithm. Have a general overview of the interface. We'll implement simple algorithms, and we'll then learn how to convert from the algorithm to the code, right? So Flowgorithm has a way that you can translate an algorithm directly to the code. So this is very practical and very important for learners, because then they learn to see how different sections of a code would translate to a program, right? Different sections of an algorithm would translate to the actual code, right? So it's very important for learners and for learning, right? For the learning process, to understand how each symbol in a flowchart translate to some lines of code or a line of code and so on. And after that, we'll go to next area, which is PLC fundamentals. We're going to be looking at a software called Logix Pro. Look at some programming logic controller basics. Look at simple start-stop circuits. Look at a very practical example, which is a door simulator, silo simulators. We can look at general sensors and actuators. We'll look at Proteus simulation skills, and this is very important because sometimes you want to realize certain projects, but you don't have the physical hardware equipment, right? So you can use Proteus to simulate all of that, write your code, connect, wire up the circuit in Proteus, simulate the code, and see how it behaves. And you have all the interfaces like screens, keyboards, keypads, LCDs, and so on. So we also learn a very useful technique, which is that of creating net labels, right? For neat wiring, Proteus is very important, especially for very large circuits. You don't want it to clutter the whole circuit. You don't want wiring to clutter the whole circuit. Also learn debugging Proteus and go to the Arduino fundamentals. Look at the general view of an Arduino board. First program, look at digital inputs and outputs on the Arduino board. Look at practical projects now. Interfacing, display interfacing. Now, what we understand from the syllabus is that interfaces are a very pertinent part of the industrial computing syllabus, especially for the practical part. So that's going to be well tested in the exam. So we have certain projects directed towards that. We have a 7-segment display. We have a practical project on how to implement it. You probably have display multiplexing, and we have key parts and user inputs, right? How to interface it with Arduino, and we now have how to interface an LCD using the I2C module. The I2C module is a very important module that reduces the number of pins or inputs, digital inputs that are needed to connect an LCD. A simple 16 by 2 LCD would typically require almost 16 pins to connect it. But with this I2C, which is also called a one-wire protocol, you can use just 2 wires to wire up the whole screen, connect it to your Arduino, right? So one wire is for transmission, the other wire is for reception. So that's why it's called a one-wire protocol. We'll look at that, and we have some projects and simulations in Proteus. And from there we'll have very practical projects, mini or projects, right? So we'll have digital security lock, environmental monitor, we have parking distance system, we have smart appliance timer, and many others as they come up. So that will be all for now. Watch out for our next video.